First of all, read the question, corresponding question. Horizontal surface. Horizontal surface. In the following case, block placed on a horizontal surface. This is the horizontal surface. Block that one. Okay. Experience force as given like that one 2.9 Newton. Each case find the frictional force applied by the surface on the block and acceleration of each block. Acceleration of each block. Clear or not? So how can do it? First of all, I know that make block diagram of 2 kg mass. Okay, make block diagram of 2 kg mass. That is 2 kg that is 2 kg. How much? Block diagram means represent all forces in direct contact force and direct contact force. Clear or not? On this block, direct contact force 2 into G, that is 20 Newton. Okay, this one is 10 Newton, that is contact force, that is 10 Newton, and here 2.9 Newton contact force. Now next one, this surface is a rough surface, that's why that is applied 2 forces. First one, normal component, it is perpendicular to the surface, that is N1, and second one parallel to the surface. Okay, horizontal, it is opposite to the applied force, like that one. Okay. Clear or not? This surface applied 2 forces. One thing perpendicular to surface, like that one, and second one frictional force, it is opposite to the applied force. Applied external force. Applied external force, this one, frictional force is opposite to that one. Clear or not? Now next target is, so clear or not? This is the complete block diagram of that. Okay. Now next target, we have focused on what about N1. Here N1 upward direction, this will be equal to 10 plus 20. 10 plus 20. Vertical component always balance vertical component, and horizontal component always balance horizontal component. Clear or not? So 10 plus 20, this will be equal to N1. That's why written, that is 30 Newton. We have taken G, for simplicity point of view, 10 meter per second square. Otherwise you can also choose 9.8, but we have taken, let assume for simplicity point of view, calculation easy. If you taken G is equal to 10 meter per second square, then calculation is more easier. That's why we have taken N1 this equal to 30 Newton. N1 this equal to 30 Newton. Clear or not? Now next target is static friction and kinetic friction. That is mu s into N1, here mu k into N1. Mu s how much? 0.1. N1 is 30 Newton. So we got 3 Newton, and that is 0.09 into 30, that is 2.7 Newton. Okay. Now what about A? A this is equal to F minus small f divided by mass. Okay. Clear or not? What about F? That is 2.9 Newton. And what about F? What about M? That is 2. And what about A? So we have focused on what about F. Applied force is how much? 2.9 Newton. 2.9 Newton is greater than 2 static friction? No. Static friction is 3 Newton. And this one is 2.9. So This block are moving or not? No. This block is not moving. Why? Because of applied force is not greater than 2.9 static friction. If F is not greater than, you can say that Fs is greater than after capital applied force F. So that is no motion. That is no motion. Clear or not? Because of frictional force is greater than which frictional force? Static friction. Limiting, this is called limiting. 3 Newton is limiting frictional force is greater than applied force. So no motion. That is no motion. Okay. So no motion means it's sure F is 2.9. That is 0. If no motion means acceleration is 0. So what about F? F is sure, that is 2.9. So what about F? F is 2.9 Newton. That force is called static frictional force. Okay, that is called static frictional force. Clear or not? Make it. That is static frictional force.